Right. In this session, we're going to go over a few more terms from set theory, as well as tie that into some Venn diagram representation of sets. So, this is more set theory terms. And Venn diagrams. Alright, so we have a couple of more terms to talk about as far as sets and how they relate to each other. And I'll show some of this with Venn diagrams as well. An intersection of sets. This is a set containing all elements shared by two sets. We denote it with what looks a lot like an upside down U, although it's a little bit straighter than that, sort of like the subset symbol but upside down. This would be read the intersection of sets A and B. Logically, you can think about it as elements that are in A and B. And if I wanted to show that with a Venn diagram, with two overlapping sets A and B, this shaded area where they overlap would be the intersection of those two sets. I should say it can take more sets as well, so you can have an intersection between multiple groups of sets. We also talk about something called a union of sets. This is a set containing all elements of each set in the union. We denote that with A and that same symbol, put up this way, which looks an awful lot like a U, which works out well if you think of it as a union. We would call this the union of A and B. And you could think of it as elements that are in A or B. Anyone who goes on to do anything computer-wise, if you work with any logical statements, these would be the basis of a couple of important statements in logic programming. So if this is A and this is set B, the union of A and B would be everything in both sets. This would represent A union of B. One other statement before we get into some practical usage of these things is A minus B. Set A minus set B. This is a set containing everything in set A that is not in set B. In set theory, that gets donated by a slash. And you'd either say that is A minus B or A not B. It said one of those two ways. And in a Venn diagram, you'd show A minus B A minus B would be this area in a Venn diagram. And obviously the order of this statement matters. If I had B not A, then I'd have shaded in my spot over here. Okay, I'm going to step through an exploration from the textbook dealing with some of these terms that we've just gone over here. So this is the exploration on page 159. Ooh, 159. Where we've got an Alberta school where there are 65 grade 12 students. Of these 65 students, 23 play volleyball and 26 play basketball. There are 31 students who do not play either sport, and they start a Venn diagram to represent the sets of students involved. So I will have my own Venn diagram here. Kind of follow along with this. I'll stick with my universal set. Here are my volleyball players. Here are my basketball players. It makes sense to have an overlap because you've probably got some people who both play volleyball and basketball. So here's my V. Here's my B. And then I'm going to start by thinking of what I've been told. Notice I'm not even getting into any sort of question at this point. I'm just looking at how to represent this data that I've been given. I know that there are 23 people who play volleyball. So in the set of volleyball players, there's 23 elements. Similarly, in the set of basketball players, there's 26 people. And there's 31 people who don't play either sport. So I'm going to leave that for now, but I'm going to fill in that piece of information into my Venn diagram. There's 31 players outside the bubble. Now, I also know that in the universal set, that being the set of all grade 12 students in the school, it's 65. One thing you might note is that 31 plus 23 plus 26 does not add up to 65. It adds up to a bit more than that. The reason for that is because we end up overcounting this area. Anyone who's playing both volleyball and basketball would be double counted if I just added these three things up. So I start to think of things a little bit more. Now, in the terms of what I had written before, I can think a little bit about what the intersection of sets would look like and union of sets and all that sort of thing. So first of all, I know that the number of people in the union of these two sets has got to be the number of people in the universal set minus 31. Has to be. There's 65 people in total. 31 of them don't play volleyball or basketball. So everyone else has got to be within this group. I keep wanting to write that as a U, but it's a slightly different symbol. And that works out to 34. So that means combined there's got to be 34 elements between these two sets. Doesn't tell me how much is in each little grouping, but I know it's 34 in total. Now, you might be tempted to think the number of elements in the union of those sets is going to be the number of elements in group V plus the number of elements in group B. But there's a problem with just adding these two together, and as I mentioned before, It's that we overcount this area. So since we've double counted that, I'm going to take that off the end. This, by the way, is a result that crops up fairly often in set theory. It's referred to as the principle of inclusion and exclusion. And it's just basically a check on avoiding double counting certain regions of the space here. Now if I fill in some values, I know that there's got to be 34 elements in the union of the two sets. There's 23 people in volleyball. There's 26 people in basketball. So that's going to tell me ultimately how many people are doing both. 34 equals 49 minus the number of elements in that set. Then negative 15 equals the negative of that. Or there are 15 people in the intersection of those two sets. And at that point, I've got enough to figure things out, to put down who's in what group particularly. I haven't even really thought about what I'm being asked for in the question. I'm just trying to sort out my Venn diagram to see where everything goes. A couple of last things, although you could probably intuit them a bit more from this. The number of people in group V minus B. So everybody who just plays volleyball, that's going to be the number of people in V minus how many people are in the intersection. Basically the whole group minus this chunk. Or 23 minus 15 equal 8. Similarly, the number of people in B minus V, and that is the number of people who play basketball but not volleyball, would be the number of people who play basketball minus the number of people who play both. Or 26 minus 15, or 11. So on my Venn diagram at this point, I can say there's 8 people who only play volleyball. There's 15 people who play both volleyball and basketball. And there's 11 people who only play basketball. With your Venn diagram filled out, you should be able to check to see whether you've matched up with everything that your situation gave you. So we were told that there are 65 grade 12 students. If you add up all these numbers, it should add up to 65. 31 and 11 is 42, 42 and 8 is 50, plus 15 is 65. That checks out. Of these students, 23 play volleyball, and there are 23 people in the volleyball group. 26 play basketball, there's 26 in the basketball group, and 31 don't play either sport, and they're outside the whole thing. If you wanted to write this in notation, what you could write is that the number of people who are in the complement of the union of these sets, I should go in the same order that I did for everything else, I guess. So this is representing everything outside the union of volleyball and basketball, which would be 31. And then I can kind of step through some of the questions here. The big question on the exploration was, how can you use this Venn diagram to determine the number of students who play volleyball only, 8, basketball only, 11, and play both, 15. Flashing back to the school days, I was going to ask if anybody had any questions about that. Hurts a little bit. I'm probably going to leave the explanations of things at that point. I'm going to put this side back over again for a second. Because I am going to attach a few questions in the Google Classroom with this video, but I'm also going to mention a few more examples for you to read. I know normally I would go through the examples, but I think these will be a bit more helpful for you to read through and to see where their numbers are coming from. And as always, if anybody goes through things and wants to shoot off some questions to me, I am usually available. Alright, that's about all I have to say on this. Thanks for listening, everybody.